All right, we are going to go over the June 2022 Part A questions from the New York State Chemistry Regents Exam. Part A consists of 30 of 50 multiple choice on the test. To keep everything in perspective, you have to earn 50 points out of a total of 85 just to earn a 65 on the Chem Regents. You want to practice every part of the exam. Personally, I think from part A, then there's B1, B2, and part C. It's not so much the questions get that much harder, but part A is predominantly going to be your definitions and your facts, things you have to memorize, things when practicing questions over and over again, you get a better handle on. The other parts of the exam, you're going to have some of the math, some of the relationships. Of course, then part B-2 and part C are all fill-in type answers. You don't have the multiple choice and the benefit of answers in front of you. Keep practicing and let's get started. Question 1 is just an information, a memorization type question. Subatomic particles are matched with their charges. You have to remember protons, pp, are positive, electrons are negative, and neutrons, of course, have no charge. Then just go through the answers and keep on eliminating choices till you get to the right one. Choice 1 can't be the answer. Neutrons aren't negative, they have no charge. Forget choice 1. Choice 2, protons are positive, electrons are negative. There's your answer. Stop right there, keep going. If we look at question 2, which conclusion directly resulted from the gold foil experiment? This is part of atomic theory. The gold foil experiment, your teacher probably mentioned the word Rutherford. He was the scientist that came up with the experiment, and there were two main conclusions: that the atoms are comprised of mostly empty space, and there is a dense, positively charged nucleus. Of the two, you'll notice here it is, choice 1 is the answer. Question 3, bright line spectrum of an element is produced when excited state electrons. In order to get excited, an atom absorbs energy and the electrons move further away from the nucleus. But what's going to happen is they don't stay there very long. In a split second, they move from higher back to lower energy states and release energy. That's exactly what you're looking for. So if they're already excited, they're going to want to release energy and they're going to move to lower energy states, which is choice 4. For question 4, the elements on the periodic table are arranged according to increasing. It is going to be increasing atomic number. Atomic mass does increase for a while pretty systematically, but it's always by atomic number. Notice these are facts that you need to know. Let's go to 15. Atoms of which element in group 15, question 5, have the greatest electronegativity? Well, electronegativity shows up quite a bit on the exam. Here's an example. It's an atom's ability to pull an electron towards itself. There is a reference table, the most underutilized reference table. That's the dog Redford, and he's saying, yes, it's reference table S. Let's go take a look. All right, here we are at reference table S. There it is, electronegativity, and we're looking for arsenic, bismuth, nitrogen, and phosphorus. I see nitrogen. Where are you, nitrogen? Here you are. 3.0 for nitrogen. Phosphorus is 2.2. Nitrogen's higher. Now we got to find arsenic is 2.2. That's still less than nitrogen. And finally, bismuth at 1.9. The answer obviously then is nitrogen. Don't be lazy and not look at the reference tables. Please, when you're practicing, look at the reference tables. Don't think, oh, yeah, I know where to look. You want to practice completely. Otherwise, you might make a careless mistake on the exam. All right, so the answer for question 5 was 3. You can memorize periodic trends, but you don't really have to. You can use reference table S, why guess, and not be sure when you can use reference table S. All right, 6 is pretty much a straight definition. Which term represents the simplest whole number ratio of atoms of the elements in a compound? That's going to be your empirical formula. For number 7, how many electrons are shared in a triple bond between two atoms? When you have sharing, that's covalent bonding, that's 2 electrons per bond. But I have a triple bond, that's 3. 3 times 2 is 6. For number 8, what occurs during this reaction? Well, I have chlorine bonded to another chlorine, and obviously we've broken the bond. This is what I call a 2-for-1 answer type question. So the first thing is let's get half of it correct. The bond is broken, so it cannot be 2 and it cannot be 4. Anytime something is broken, the energy has to be going in or absorbed. Think of breaking a bone. If you break a bone, then you probably got hit with something or you ran into something, right? Energy was absorbed. So the answer for number 8 is 3. All right, question 9. Now, this happens a lot also with part A. They're talking about krypton atoms. If you don't know, krypton is a noble gas. It's going to be found in column 18, and it has the symbol Kr. Once again, our most underutilized table, table S, don't guess. Here it is, krypton, right, Kr. Then when you go and look at the periodic table, lo and behold, you're going to see it way to the right, the last column, which makes it part of the noble gases. What do we know about noble gases? They have stable electron configurations. All of the elements that make up the noble gases, with the exception of helium, which the magic number is 2, the rest, the magic number is 8. 8 valence electrons. And there you are with your answer, which is choice 4. Okay, for question 10 is really a definition type question, right? All matter can be classified as, well, matter is elements, matter is compounds, and matter is mixtures. But elements and compounds are known as substances. So our answer here for question 10 is 4. Very interesting question 11. First time I'm really taking a look at it after the Regents exams this year. Which sample at STP has the same chemical properties of 10 grams of a solid aluminum? Well, solid aluminum, 10 grams, whether I have 100 grams or 1,000 grams, the same chemical properties is going to be 5 grams of aluminum. Silicon, sodium, and magnesium have their own properties. I think somehow the New York State writers are trying to trick students with the gas law question with the number of particles at STP. But this is a totally different question. So chemical properties, it doesn't matter how much of an element you have. If it is that element, it's going to have the same chemical properties. For question 12, which sample of matter cannot be broken down by chemical change? What we're talking about here is an element. Remember, compounds you can break down. So what you have to do is recognize that antimony is an element. All the other 3 are compounds. Remember, you have reference table S to go back and double check your elements. There's the whole list there of the element names. All right, 13, based on table F, which 10-gram sample, when thoroughly mixed with 1 liter of water at room temperature, forms a heterogeneous mixture? Heterogeneous means it's not going to look the same throughout. Let's take a look. So for reference table F, we're looking at what's soluble in water and what's not. If it's soluble, it should disappear in water until we put so much in it would be saturated. If it's insoluble, we're going to put it in. A little bit is going to dissolve, but really all it's going to look like is that the salt is just falling to the bottom of the container. Really what this is asking is which of the 4 choices is insoluble in water. When you use reference table F, you literally have to take the formula and break it apart into the positive and negative ions to get the answer. There is an answer of the choices that has ammonium, and ammonium is always soluble. There's potassium in another choice, group 1 ions, which potassium is part of. They're always soluble, and nitrates are always soluble. It's the silver bromide. See, bromides are normally soluble, except for these three metal ions bonded to chloride, bromide, or iodide. So silver bromide is going to be insoluble, and that means when I put it in water, it's going to essentially just fall to the bottom and be heterogeneous. So that's our answer, which is choice 3. All right, for question 14, this is known as colligative properties. In other words, you have water, water freezes at 0 degrees, boils at 100 degrees. When you dissolve something in water, the boiling point gets elevated and the freezing point depresses or drops. Well, two ways that happens. One is something soluble and it breaks apart into ions. Those particles, those ions, will have an effect on, again, the boiling point and the freezing point. Sugar and alcohol molecules will as well, but any salt is going to, at a minimum, if it's soluble, break up into two pieces. So it usually has more of an effect. In this case, we're dealing with the same salt. We're dealing with NaCl. But the difference is 1 molar solution versus 2 molar. So if we have more solute in a given amount of water, again, the boiling point's even going to go higher and the freezing point lower. So we got to make sure we're just reading this correctly. Compared to a 1 molar sodium chloride solution at 1 atm, a 2 molar sodium chloride solution at 1 atm is going to have a higher boiling point and a lower freezing point, which is choice 3. For question 15, which list includes 3 forms of energy? Again, vocabulary, vocabulary, vocabulary. Temperature is not a form of energy. So stop right there. Get rid of temperature in choices 1 and 2. Alkalinity in choice 4, that has to do with how basic, right? Like sodium hydroxide is a base. How many hydroxide ions you have. That's not a form of any energy either. So the only answer that makes any sense here is choice 3. There's electromagnetic energy, nuclear, and chemical, among others. 16. Under which conditions of pressure and temp is a real gas behave most like an ideal gas? It's always going to be low pressure, high temperature. Always. Low pressure, high temperature, which is choice 2. A fact. You have to know your definitions. You have to know your facts. Okay, question 17. This is what I was talking about before with question 11. Now we're talking about gases. In order to have the same number of atoms, argon is a noble gas, helium is a noble gas, we have to have the same moles of gas. So that means our volume, our pressure, and our temperature, we want exactly the same. All we're doing in question 17 is matching up the 100 mils, the 1 atm, and the 300 K, and that is choice 4. For 18, which process is a chemical change? Once again, vocabulary, vocabulary, vocabulary. Synthesis is the answer here. Synthesis, deposition, single replacement, and double replacement are all chemical reactions or descriptions of chemical reactions. Condensation, evaporation, sublimation, melting, boiling, those are all physical changes. For question 19, which property is determined by the structure, arrangement, and interaction of molecules of a substance at a given temperature and pressure? Okay, so for this, the property, right, when it's dealing with structure, arrangement, and interactions, has to be the physical state. The other 3 choices make no sense. But again, you got to know your vocabulary. All right, question 20. We're talking about collisions. This has to do with kinetics. And in order for collisions between reactant particles to have the bonds break and bonds form, which is known as effective collision, you have to have 2 things. You have to have the proper orientation, right, of those molecules or a molecule and atom, whatever those particles are, hitting one another, and the right amount of energy. Again, 20 is just a fact. 21. Here's another fact that you need to remember. You're dealing with equilibrium, right? Which statement describes this reaction at equilibrium? Remember, at equilibrium, it's the rates of the forward and reverse reactions are equal. Concentrations remain constant. The rates are equal. So let's take a look. So choice one rather says the concentration of the reactant and product must be equal. That is incorrect. The concentration of the reactant and products must be constant. There you go. It's choice two. And the rates of the forward and reverse reactions, they are not increasing. They're not decreasing. Okay, those would be equal. All right, let's check out 22 and 23 here. Which phrase describes the effect of adding a catalyst to a chemical reaction in order to increase the reaction rate? Well, you should have learned in class that catalysts somehow change the reaction pathway. In other words, to go from reactants to products. Sometimes it can happen in one step, maybe it's several steps. And as a result, the activation energy, the energy required to get any reaction, whether it's endo or exothermic started, would get lowered. So my answer for 22 is choice one. For 23, systems in nature tend to undergo changes towards. Again, here, just like 22, these are facts that we want lower energy and greater disorder. That means lower energy means lower enthalpy, greater disorder means more entropy. So sometimes they'll use the words enthalpy and entropy for this type of question. In this case, they use energy and disorder, which is choice three. Alrighty, for question 24, which element must be present in an organic compound? If you don't remember that carbon is the element in organic compounds, then you're in big trouble. This has to be probably or was the easiest question on the test. Now, 25, you have to do a little bit more thinking. Which formula represents a saturated hydrocarbon? There are unsaturated hydrocarbons and saturated. Your saturated hydrocarbons are your alkanes. Your unsaturated hydrocarbons are your alkenes and alkynes. Now, each one of those hydrocarbon series has its own formula for calculating the number of hydrogen atoms that go along with the number of carbons. Let's take a look. Notice that choices 1 and 2, we're talking 2 carbons. Choices 3 and 4, we're talking 6. That's going to be important. Let's take a look. Okay, so again, your saturated hydrocarbons are your alkanes. Your alkenes and alkynes are what's known as unsaturated, because you have double bond between carbons and a triple bond between carbons. You could open up one, or in the case of triple, 2 of those bonds and add more hydrogens to it. So that's why it's called unsaturated. Now, with alkanes, here's my general formula. When I have 2 carbons, the amount of hydrogens to make it a saturated hydrocarbon, also known as ethane, would be 2 times 2, which is 4 plus 6, would be C2H6. We'll see if that's one of the choices. The other one had 6 carbons to start. The number of hydrogens now for hexane, well, 2 times 6 is 12, plus 2 is 14. So either one of these will be the answer there for that question. All right, and there you have it. It's going to be choice 4, the C6H14. For 26, what occurs at the anode in an electrochemical cell? Anox, red cat. Anode is always oxidation. It is a fact, Jack. At the cathode is always reduction. You have to know it. All right, some more facts here. Which statement describes the 2 types of reactions that occur in operating electrochemical cells? 2 types of cells, your voltaic, that's spontaneous, that's going to produce electrical energy from chemical, and then your non-spontaneous, which is your electrolytic cell. That's where it requires electrical energy to get a chemical reaction started. With that information, let's just run down the choices. So choice 1, non-spontaneous occurs in voltaic. That's wrong. Throw it out. Non-spontaneous occurs in electrolytic and non in voltaic. That's wrong. Spontaneous occurs in voltaic and non-spontaneous and electrolytic. There's my answer. For 28, which term describes an acid according to one acid-base theory? Again, there are two acid-base theories that you have to know for the Chem Regents. Arrhenius' theory, where an acid provides H plus in solution, and Bronsted-Lowry theory, which is here, where H plus is a donor. So that would be choice 2. Again, facts, definitions, you got to know. We only have 2 questions left here. Alrighty. For 29, which emission will be released from an unstable iron 53 nucleus? Well, you don't have to memorize this. Here's where you have to go look. You got to go look at the reference tables. Let's do that right now. Alrighty, iron 53, we find it on reference table N, and it is a beta plus, which is also known as a positron. So it's positive beta decay, or a positron being emitted. Let's go back and take a look at the choices. And there it is, choice 3, positron. And then finally, question 30, what is the potential risk associated with radioactive isotopes? Well, a risk would mean that it's something that could be a problem. And for that, we would say, of course, biological exposure. All right, that's the first 30. I hope that you're learning from your mistakes, that I'm helping you in explaining information. Check out the other parts of the Regents exams. I have a whole bunch on here on nychemcoach.com. I also have some study materials. I'm going to show you where those are right now. All right, this is my website called petplushuman.com. I sell t-shirts that have to do with chemistry, science, and pets, because that's what I like, quite frankly. But here, if we scroll down, there's, of course, YouTube videos, there's more, and then here's more information. Urine Review is going to have all those bits and pieces of the facts and the terms that you need to know and memorize. It also helps, of course, to go over as many questions as you can. Just keep working hard, and good luck.